Let me do this integral by two methods. Okay, the first method, method 1, I let x be pi minus t. So the integral becomes pi minus t, and sine pi minus t is the same thing as sine t. So this is sine 5th power t and a negative dt. The boundary will be changed from pi to 0. Then I use this negative to switch that the boundary to becomes from 0 to pi, isn't it? Now t and x is just dummy variable. I can write x instead. Pi minus x sine 5th power x dx. All right, so it becomes pi times 0 to pi sine 5th power x dx. And x sine 5th is the same thing as my target integral, which is I, right? So my I would be equal to half pi. 2I is this, because I becomes half pi times integral 0 to pi sine 5th power x dx. This is equal to half pi from 0 to pi. Now sine 5th is sine 4th times sine. Sine x dx is this is a sine 4th x times sine x dx is d cosine negative, right? I leave negative outside. Then this becomes negative half pi from 0 to pi. This is 1 minus cosine square x, right? Square and a d cosine. Yeah. So this becomes a half pi from 0 to pi. This is 1 minus 2 cosine square x plus cosine 4th x and a d cosine x. So this is obvious. This is a minus half. This integral is cosine. This integral is 2 over 3 cosine 3x plus 1 over 5 cosine 5th x from 0 to pi, isn't it? So this is half pi. Half pi. This is negative 1. This is positive 2 over 3. This is a negative 1/5, and a minus 1, and a plus 2 over 3. This was minus 1/5. And you simplify them. At the end is 8 pi over 15. So that is the answer for this integral by method 1. Okay, that's method 1. Now, method 2. I is equal to 0 to pi x sine fifth power x dx. Method of 2, I let x be half pi minus t. Okay, this is from 0 to no. I'm sorry that I don't know why this one. This is equal to integral x is a half pi minus t sine half pi minus t becomes cosine. Cosine is pi t and then negative dt. And this will be 0 is half pi. When x equals to pi, this is negative half pi. So I use this negative to switch that interval from minus half pi to positive half. So the negative is gone. It becomes the first integral is half pi and cosine fifth t dt, isn't it? The second one will become plus t cosine fifth t dt. Okay, from minus pi to this one. As we know that cosine function is a even function. Now when you multiply by t, so it becomes odd function. This is symmetrical boundary. You see, therefore this integral is 0 because this is a odd function. So it becomes half pi from negative half pi to positive half pi, and I can write x for t, right? This is cosine fifth x dx. Yeah, this is a half pi from minus, no, this is even function. So I can change it, this one to from 0 to half pi times 2, right? Times 2. And cosine, I can write cosine fourth x and cosine x dx. All right? This 2 because this is even function. I can write from 0 to half pi for times 2. So it becomes pi and from 0 to half pi, and cosine fourth is 1 minus sine square x square, right? Cosine x dx is a d sine x. So this becomes pi times 0 to half pi. This is 1 minus 2 sine square x plus sine fourth x d sine x. So it becomes pi sine x minus 2 over 3 sine cube x plus 1/5 sine fifth x from 0 to half pi. So this one is equal to pi minus 1 minus 2 over 3 plus 1 over 5. Yeah, that is equal to the same thing, 8 pi over 15. Okay, this is a nice method, as good as the first one. Thank you for your watching.